Alright, section 4.5 is looking at solving quadratics by finding square roots. So first thing we need to do is practice finding square roots and simplifying those. So we'll look at a few examples to start off with. We're just going to simplify. Okay, and the first ones I want to look at is square root of 75. And I don't want to put this in the calculator because I know that 75 is not a perfect square. So I like to use what's called a factor tree. And I want to break this down into a product of prime numbers. So I know that 5 goes into 75. I know that it goes into it 15 times. 5 is a prime number, so I can stop there. 15, however, is not. 15 can be broken down to 3 and 5, and both of those are prime numbers. Okay, so now that I've got it broken down to 5 times 3 times 5, those are all prime numbers. Since it's the square root, I have a pair of 5s, so that 5 can come out, and the 3 that's all by itself in the square has to stay underneath the radical. Okay, that's question A, we'll say. Question B, we have square root of 7 times square root of 35. And we could multiply 7 and 35 together and say this is really the square root of 245. But you kind of do that and then you work your way back again, because factors of 245 you know are 7 and 35. 7 is a prime, 35 is not. 5 and 7. 5 and 7 are both prime, so you have a pair of 7s. So that will come out. The 5 in the square is all by itself. It stays underneath the radical. Question C, very similar. Have square root of 100 over square root of 169. And if you have a radical engulfing an entire fraction, what you can do is separate that to 2 radicals, and then you just say, well, square root of 100 is 10, square root of 169 is 13. That's all you have to do. Question number D, last one of this part. We have 11 over 44, or 144, sorry. So again, break this up. Square root of 11 will not simplify, so leave it as that. Square root of 144 is 12, therefore that's your answer. Alright, sometimes we'll say, this is example 2 here, sometimes we have things that will not reduce as nicely. For instance, square root of 2 over 15. Okay, this is something where if you break this up, square root of 15 does not reduce, so we need to do something that's called rationalization. So we want to rationalize the denominator by getting rid of the radical. So if I multiply the top and the bottom by square root of 15, all I'm doing in essence is multiplying by 1. 2 times 15 is 30. And 15 times 15, once you multiply the same thing by itself with a radical, it just cancels out the square root. And unfortunately, if you look at 30, 3 and 10, 2 and 5, there are no pairs, so this is your answer. It will not simplify any further. Alright, another type of question is a question like this. We'll say this is A and that's B. Let's say we had 4 over 5 minus square root of 2. This one's not as simple because we have to rationalize, but we have to rationalize by multiplying by the conjugate, which is the opposite of what's on the denominator. So when you do that, in essence what you're doing is you're distributing on the top and you're doing the FOIL process on the bottom, and in doing this you should get rid of your square roots altogether. So distribute, 4 times 5 is 20, and 4 times square root of 2 is 4 square root of 2, and on the bottom you get 25 plus 5 square root of 2 minus 5 square root of 2, and then negative square root of 2 times positive square root of 2 is negative 2. They cancel every time. 25 minus 2 is 23. Nothing else simplifies, so that's your answer. That is the first half of section 4.5 with simplifying radicals.